Hello, welcome back to Blender Sushi LiveENODING. In this episode, we're gonna take a look at this node tree, which is actually kind of half based on tutorial by Inigo Quilez on his YouTube channel. I think he was using Excel to kind of generate this kind of imagery of like a flower, and everything was actually made using just math formula. So I try to recreate the same thing using Sverchok nodes in this case. You can actually do this very similar thing using Blender cycle nodes, or EV nodes even. And it's gonna work in real time as a shader. So this is the whole nodes. It looks like there are plenty of nodes and looks scary, but they're not actually that scary because these nodes, for example, and these nodes are actually the same, and they are actually controlling the size of the flower, the middle part of the flower, and I simply add them. So in a way, you can look at this like there's like a flower, and there's also the circle, and the flower petal thing is actually based on the circle, and I simply use another formula. It's based on Inigo Quilez. Actually, I think it's his cute flower tutorial. So based on the column and the rows of Excel, you can create this flower. Okay, how to code and animate flower in spreadsheet. It was added only a month ago. Highly recommend it. And and he is using math formula, which I converted into nodes. My internet is super slow here, but it's gonna load eventually. So let's have a look how I did it in Sverchok. You see the last nodes here. This is the texture viewer, and I'm using this pass. So this one is passing it into the image viewer, image editor, and I simply pick up this texture. And the texture size is only, this is like 50 by 50. Yeah, this one is using Google Spreadsheet. Not recommended, but you can do it using Google Spreadsheet. It is easier to do it in Blender. This is 50 by 50 pixel, of course. So how I started, I basically started with this plane, and for the plane I give it points, 50 by 50 points, and I use this normalize as well, and I set it so it's X and Y is putting all the points, and from the points I simply separate the vector value. So you can see here this vector out, and from the vector output there is X and Y value for the plane, kind of like a grid. You can think of the column and the row, and using those value I use this sub. If I move this around, you can actually start to see, okay, why I have this value over here. It's moving it ups and down. It's kind of like putting the dots in the center of this image, center of this frame. And there's this formula that's kind of looks scary, but this formula is actually to kind of calculate the distance. So the distance between one point and the other points allows you to generate circle shapes. Okay, that's why we have this square roots and the power of 2. This is, I think it's based on this formula to find the distance. And then we have this sub. This one is controlling, seems like it's controlling the size. The petal the petal itself is using this formula, A tangent multiply cosine. So this formula is something that you can probably search online, and then why it comes into this formula, and why we can have petal based on this formula when we mix it and add it together with the circle. So sometimes it's interesting to understand that, but you don't need to understand 100%. You just know, okay, this creates petal and this one creates circle, and then the rest of them we have powers, minimum and maximum. This one is actually Inigo Quilez used this minimum and maximum functions. It seems to behave slightly differently in my case. It seems to be like clamping the value, so you only have like shapes instead of like a gradient. It's hard to understand. It's almost like this map range with the clamp turned on with a minimum and maximum. So it's increasing and decreasing the contrast, I think. So yeah, so I keep going with this, and I have this one, another circle. It's exactly the same as this one over here. So this is that same circle formula. I just add them together. It's kind of like layering in Photoshop. If you have circle and you have the petal, and then you add them together, you have another shape. Here I have a lot of things going on, but it's basically, this is RGB. This is RGB output for this texture viewer. Oh, by the way, by any time, if you want to see the texture, you can actually use this and show the result. If I'm not wrong, for example, let's go back here, and based on this plane, for example, we have the X and Y. If we plug this into this guy, we should have result. So this is how you preview. You can see the gradient, right? Because the value of the X and the Y of a plane will grow in certain directions. And using both value, that's why using both value and find the distance formula, we're gonna end up with a circle. Okay, and then if we continue on, we have all this subtract, and then the power, this A tangent stuff is actually looking something like this. This one is the one that's driving the circle, so it looks like a petal. So if we continue, this minimum and maximum is kind of adding and decreasing the contrast. You actually want to get just the black and white color, I think. Yeah. Anyway, all the way up to this, the final result. This is this vector in that takes the value from X, Y, Z. We don't have anything on the Z, but if we animate the Z, we're gonna have this psychedelic effects. And we have, I think we can also use different math, but doesn't matter. This one, putting all those values that we use originally from plane all the way until we get the flower, and then from here we simply use the value as RGB. I'm using vector noise just to make things a little bit funny looking, but originally it's this is actually, oh, you can't really see it unless you have the proper value here. It was actually black and white, and I use this map range. So if I actually plug this into that guy, and then simply using the black and white, this is the original shapes, like a kind of like a faded, like ghostly flower. But from this single value and then this map range, I simply kind of remapping this value into the red, green. This is X and Y. The Z we don't use. And if I plug this into that guy and turn on RGB, we should get a, okay, there you go. We need a proper red and green value adjusted until it makes sense. But if we use vector noise, it will remap it into the noise, and that's why we have this. So this is like a kind of like a magic actually, because there are value that's outside and inside of the value you are seeing, and then you remap it into vector noise. That's why you have this result. Very interesting, right? So that's why I want to share it with you. It's a good for you if you are learning to code shader, or if you like to use like a visual ways to understand things. So this is important, the X and the Y. You can actually generate this using cycles once again, but you can also use I think that there's a visual graph editor for Unity or Unreal Engine. It's very, very similar. All right, and you can use this gradient, flower, whatever, and you can use it to actually to animate objects or geometry, or to actually generate shapes. And yeah, so hopefully this is useful. Let me know what you think, and I'll see you next time. Thank you. Bye.